Okay, let's first, it's actually also good sometimes for you to do this when you want to know what inherits from what, and to have a template, to have a plan for creating these uh, is now being recorded for creating these classes. So, not to deviate from what we've discussed so far in terms of the examples we've given, I'm going to basically implement this structure today. And the structure is we're going to create an animal class, but this animal class is a little bit different. It is a pure abstract class. And for this pure abstract class, uh, I'm basically going to have um I'm basically going to have a um, I'm not going to have any member function, and if I can change it here, no member function. So uh, I'm putting nothing for the member function. It will again have it will again have these functions: act, which is pure virtual, and it will have move, which is again pure virtual. Maybe we can make them a little bit bigger. Move, pure virtual, and sound, again pure virtual. And on Tuesday session, we said that by pure virtual, we mean there is no implementation for uh, this member function in that class. And this is just we by doing this, we put equal to 0 in the header file for the virtual function, and we don't implement anything in the CPP file, and that makes it a virtual, pure virtual function. We said that any class that has at least one pure virtual function is called an abstract class. An abstract class, because of lack of implementation of at least one of its member functions, is not instantiable, is not a class that you can use for instantiating and initializing an object. It's basically a roadmap, an interface, a roadmap for the classes that are being derived from this class. And uh, so let's see how that roadmap works here. Here, basically, what I'm going to implement in an animal is nothing, and I'm just gonna put uh, pure virtual member functions. There's even no member variable. So what good does it make? We will see at the end of today's class. We will see how we benefit from all this. Um, and then, okay, now the second class I'm gonna create is actually, let me copy paste this from here. Um, I'm gonna create. Did I? I think it duplicated this. No. Okay. I'm gonna create another class that inherits from the animal class. I'm going to call that pet, class pet. Uh, this is also an abstract class, an abstract class. And in this abstract class, I'm going to come here and ask you guys, what do you think I must put here? We can put anything that we want, but there are something that are must to write here. Uh, can somebody unmute and uh, explain what are the things that are a must, assuming that this pet class is inheriting whatever animal class has. Assuming this, now what should be written here for sure? I mean, what is that thing or those things that if I don't write here, I'm not gonna even have an inheritance. I'm not gonna even be able to compile this code. Anyone? Nobody? Those are obviously these member functions, because that's what we said on Tuesday. We said that when we have an abstract class as a base, like animal here, and we want to derive another class from that, it the presence of pure member functions in the base class dictates, forces uh, the derived classes to definitely have those uh, member functions in their basically in their class. You see, if I don't put act, move, and sound here, I'm gonna get a compiler error, and these are must because they were in the parent class and there was no implementation. If there was an implementation there, we were good. We could skip some of these. And for this one, I'm gonna add a member variable called name. Now we have pet, and let's say we will. Let me see what I have done here. Is okay. We're gonna we're gonna have this act implemented here, and leave the rest. Sorry, leave the rest. Again, virtual member functions. And from this one, we're going to drive two other classes that are both inheriting these. One of them is dog, and this dog will have the implementation of the things that are not implemented in its base classes. So these are basically these are um, these are dog. We're going to say dog is going to have an age, and is going to have an age, and then the dog is going to have all these actions with plus their implementation. This is basically the point when we implement these. These functions are not pure virtual functions anymore. And from this stage, if somebody wants to inherit, which now again we'll see, uh, if something wants to inherit, it can decide if it wants to shadow any of these functions or just use its parent, which is dog function. So uh, if I come down here and implement implement a puppy class, it will also have its own functions, but having having uh, move, act, and sound is not mandatory anymore. Until this stage, it was mandatory because some of them at any stage in the hierarchy tree, uh, if you implement one of these pure virtual functions, from that moment on, anything after that have the option to choose if they want to shadow that function or if they don't want to shadow that function. But until a function is pure virtual, you have to repeat that in the derived class, in the child class. So here, this is gonna have um, puppy is going to have a weight, and then it's going to have a let me see what we have here. Let me see. For Poppy, we have move. We have shadowed. I have also implemented this to shadow move. And now another class. So another class we will create uh, called rabbit, and that rabbit will also implement it has to implement all the parts that was pure function in its parent in pet, just like what dog did. And here it's going to have a color as its member function, and it's going to have uh, again act and move and its sound. And these classes from inherit these are inherited. If I want to show like this, it will be like this, and this is also inherited from pet, and inherits from puppy inherits from uh, dog. Okay, and I want to share this picture later on our GitHub. Okay, so this is how it looks like. Uh, this is how it looks like, and we're going to create all these classes. So take home message of this is uh, you have to repeat the member functions that you have not implemented in any class when a class is going to be derived. So here pet could have anything, but this act and move and sound, having these was a must. It must pet must have these because these are pure virtual function in its previous level. Are we good with this problem definition so far? Yi Liu, you said no. Misclick. Okay. Okay, very good. Now we're going to implement this in our code. Going back to the code, maybe I can just close this for today during the session. Okay, let's start with our animal. I have the files here. They are ready. We just need to go ahead and implement based on what we said. So here I'm going to create a class animal, uh, which is a which is a base class, and we said that it's not even going to have any member variable, and in its public it's going to have uh, these uh, these classes: animal act, animal uh, move, and animal sound, and of course animal animal sound. And obviously, I should also have a destructor. Well, this is something that we will always have. Um Animal. Why? We said why. Is there anything missing here, people? Well, something is missing. What is that missing thing? Now I'm going to implement this, and these are all going to be, pet is going to be derived from this class, and these are going to be derived at the end of the day from pet. What is missing here in this in this small piece of code? Can somebody tell me what is missing? Well, two things missing. Public chat. Okay. Sebastian. A constructor. Sebastian, you said a constructor. That's a good point. Let's discuss that. Uh, why do I need a constructor here? Why do you think I need a constructor? What was the role of a constructor? Exactly. Yes. So that's optional. I can have a constructor here, but that constructor will make no good for me because I don't have a member variable, and it will not compiler will take care of this. So I don't need, unless I want to write some debug messages or things like that. Are we on the same page, Sebastian? Okay, great. Well, what is missing is, first of all, we said that I'm gonna make these in our plan. We said that I'm gonna make these all pure virtual functions. And if you look at this, as soon as I make these pure, I make these pure virtual classes. What is this? Specifier load only on virtual functions. So these are virtual. Yeah. As soon as I put this equal to 0, you see this thingy that is telling me, okay, now you need to go and implement this disappeared, because compiler understands that I'm going to make a pure virtual member function, and I don't need to implement anything, so it doesn't show me this snaky thingy, the green thingy that usually it shows to indicate that an implementation is missing for the signature. And another thing that is missing is virtual. We need to we need to make these virtual, otherwise um, you cannot have a member function that uh, is equal to 0. It doesn't have any implementation and is not virtual. It doesn't make sense, because the whole concept of virtuality is to dispatch the implementation of these functions into into the future, into the classes that are being derived from this, right? So it doesn't allow me to make it equal to 0 unless I put a virtual to this member function. But this one, we're gonna implement this, and most importantly, virtual for this should not be uh, should not be should not be forgotten. And here I'm gonna implement this and say just a message if debug, if debug, uh, and here I can say std cout, again deleting nothing. I don't have a name. It doesn't have anything. Deleting animal. I am writing this to show that to see this message in the debug when debug is on, because I am not printing any message in the constructor because I don't have a constructor. I want to show you that even though I don't have a constructor, well, I could have, but I chose not to have because it made no good. It didn't add anything. And I'm not printing because I don't have this constructor. I'm not printing anything at the time of construction. But we will have this so that we see every time any of these classes are being, any of these objects of child types are being constructed and are being initialized, basically the base floor for all of them will be animal, and in the deletion in the at the end of the code when these objects are being deleted, we will see that animal is also being deleted. Okay, is our animal good? It's good. I don't think we're missing anything, but still we can compile. Okay, it compiled. Very good. Now, the next thing we're gonna build from the animal is pet. And in pet, we're going to have a name. So in pet, first of all, my pet class will inherit from my animal class. This is the reason I've put this thingy here, animal. I have included animal header file in my pet file. Otherwise, it will not recognize the animal. Animal uh, will be will be unknown for this. Come on, show the error. It didn't. It's a little bit too slow. For this, uh, we add this. We add the basically animal header here so that this animal is known to this guy, to this pet class. Pet class, we have mname. Uh, we're gonna choose short name, so let's make it 12 mname, and this is a string of characters mname with, and we are doing this statically, so statically its size is soon to be 12. And in the public part, what we're going to implement, again, if we go back to our sketch here, uh, act, move, and sound are all necessary stuff for this. So this time we have to repeat those. And by the way, uh, I'm putting virtual this time from the beginning. Uh, act, act. Since we're going to implement this, I'm not making it pure virtual, but for the others, we will be putting. This is the first thing you do, and then we will go and create its constructor or queries or setters, anything that it needs. Act, move. I'm not gonna implement move at this stage, and virtual pet reference sound. And again, I'm not gonna implement this at this level. I'm not gonna implement sound uh, in this part. What else do I need? Uh, because we have this member variable now, it's time to bring in a constructor, right? It's time to bring in a constructor, and our constructor will be something like this. Pointer name, right? What else? Do you like having a setter for m name and a query that we can every time we can ask for the name? Well, I think that's a good idea. So we can have first let's have a setter set name. For the set name, we're gonna get this constant character pointer again, name. And for the query, we can have constant character pointer as a return and get name. And then we should go ahead and implement these things. Uh, if you think you want to add something, please let me know. I guess with this scheme we will be okay. Uh, and if you like, I can add constant here as well, because we know that get name will not change anything. So let's put constant there. And now here, let's implement the pet part of it. Pet part of it will be created, and we need this to be created. We need this also to be created. Also, obviously, we need a destructor for this. We need a destructor. Uh, that's also for sure. We need to implement that as well. Okay, so for the construct for the let's do this first. For the setter, we can say utstr copy, and I want to copy in my m name name 12. That should do this. And utils, I've added utils actually. That's why I'm able to use this. And in the constructor, let's reuse our code and say name, and then print a debug message saying that uh, we are creating a what? A get name, a get name. We're creating a get name, the pet. Okay, that's this. That's this. And here for the get name, we simply return mname, right? We return mname, and in the pet again, in the destructor, we want to see some message. We want to see some message, and that is deleting. Deleting who? Deleting now. Again, get name. Deleting get name. The pet. Okay, I think so far so good. Uh, this is what we have. So we for the act, we wanted to add this act as well. So as soon as I implement this act here, there is no need for future classes that are being derived from pet to implement this act. But if they want, they are very welcome to do that, to shadow this act and have an updated act. Here, first I'm going to return this, the current object, which is a pet reference. And for the act, I'm going to say uh, what? Uh, uh, I'm going to just say get name the pet, the pet acts. That's it, because this is how a pet acts. Unless I know what pet I'm talking about, it will just be a general message. Okay, that's it. Let me build this. Okay, build successful. So in build, we actually implemented act and the rest of other things. And because we had a member variable, we also used a constructor to initialize that. Now, going back to our inheritance tree, now it's time to implement dog. Dog inherits from pet, and it has age, and all these functions should be implemented. If we go to dog, so now for pet, because this is inheriting from pet, for pet to be visible now to this module, I'm including the pet header file. And I can define here class dog that inherits from public pet. And now if I want to create this class, let me check something on Let me check something on pet. Okay. For the dog, we have public. And before that, we said that dog is going to have an age, int mh is this dog's age, and in public, uh, again, before we forget, those two mandatory parts, virtual virtual dog reference. What is the mandatory part? The member functions that have not been, until this stage, have not been implemented. They have stayed pure virtual functions. So that's move and sound. So here, before we forget, we put dog move, which we want to implement, and we put virtual dog reference, and we put sound, right? We want to implement the sound as well. Now it's in terms of compiling and in terms of generating sound without no error. Uh, this is good, but we also want to have some more things. One of them is the constructor of this dog, because now dog not only has an age, but also it has a name, and the name is coming from the pet part of it. So it must have a constant character pointer name, 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 and integer age. Uh, are we good with this? With this part? Uh, the are is there any question about the constructor of this dog? Okay, good. Uh, and then we said that I'm also going to implement the act of this. And what else? A destructor, obviously virtual, definitely for sure virtual. Um, and probably a setter. So we can say void set age of this dog to an age, right? And also, same way, we can have a query to know the age of this dog. And I'm gonna write get age. Very good. This is all I was going to implement for this cat. Is there anything else you want me to add? Okay. So now if we want to come there and implement these, we will see some very good stuff. Dog, get age, set age, and act, and then move and then sound, and then the destructor. Okay, now to remind you that how we used the uh, the parents constructor, because now the name part is coming from the parent, which is pet. We said that in the initialization area, we can put this, but doesn't matter. Brackets or curly brackets or braces, they're both fine. I'm using this, and this sends, this part sends name to the constructor of pet, and that pet, when at the time of creation, has enough information that it needs from the dog part. Basically, child passes its information to its parent, and the parent puts the name where it should be. And we said that we can also initialize the other part, which is age here, but I prefer to do it like this. We say set age. Now we also set the age to age. We set age here and then write a message if debug is true. Now, please let me add using namespace std here so that I don't have to repeat this std. If debug cout what uh, creating uh, creating get name. Now this get name is coming from its parent. Get name, creating this, my dog, that that is uh, get age years old. Years old. Okay. Now I'm gonna print this message when I'm creating the dog um, to to basically notify the user that I created this dog. For the set age, it's easy. Mh. We can put mh equal to age, and here we return mh, right? And here for the act, I'm gonna return this first. Return this. I'm gonna return this, and then here say um, the act of dog. What can be the act of dog? Let's say it what? It's so cute if it can shake its hand. So shake hand can say the uh, get name. Get name this is my dog that can shake hand. Shake hand. And here uh, this is the act of this dog. Now we are shadowing the act of pet. Pet also had an act. It just acted. We didn't know, but now we know what dogs are capable of, and we added this act. Here, do the same thing. Return, return this, and here say see out, get name, get name. Now for move, uh, can fetch, huh? Can fetch, and for the sound, for the sound, I'm gonna say out get name. Oh, barks all the time, but he really does. We have a dog, and that's it for the destructor. Again, the debug message. See out. Uh, see out. Deleting get name, the dog that was get age years old. Okay, implemented this, and I guess nothing is missing. Let me build this. Okay, and now uh, let's implement our rabbit. Where is rabbit? So CPP, where is rabbit? Rabbit is here. Uh, we said that now two animals are being derived from pet. One of them is dog, the other one is rabbit. So rabbit for rabbit also having move and sound is a must. Rabbit must have these, but act is optional. Let's also implement that. Class rabbit that inherits from pet, and it's going to have a color as well. It's going to have color. So character color. Again, if we choose short names, we should be good with that part. And then say public. The must have things, virtual uh, rabbit reference, um, move, and virtual rabbit reference, rabbit reference sound, and we can have virtual rabbit reference act as well. That will shadow our act. And for the Constructor, same way I can have constant character. Pointer, name again, because it will have its parent's name, and constant character pointer color. Huh? So it will have two things, color as well. And here we can have a query for getting the for setting the color, a setter for setting the color, set color, constant character pointer color, and a query for asking for the color, constant character pointer uh, get color const, and uh, that's this, and obviously a destructor, virtual rabbit, virtual rabbit. And then if we go to rabbit here and start implementing each of these, uh, it is very similar to dog, so bear with me. I know it's actually good to repeat these so that everything solidifies. And here I'm creating these as well. Okay, for the constructor, using the same old friend, our good friend, pet name, uh, and here I'm gonna come down and say ut.str copy. Now mColor, I'm gonna copy this color here, 12, and what else? What else? Color. What's wrong with it? Is rabbit not identified? Color. Oh, sorry. It's mColor. Okay, mColor. And here, well, let's do it this way. Color. And here, just say set color. Color. And if this, I'm gonna print this message, cout namespace std. I'm gonna cout creating um, creating get name again, get name, the uh, get color rabbit, and that's it. And here for the get color, we're gonna return mColor, and for the act, we're gonna return this, and we're gonna say see out when we want this to act. We can say uh, get name uh, jumps, or that can be a formal choose uh, handle. And here, let's do the same thing. Get name, and do the same thing here. For the act, we're gonna say jumps, and for the sound, I'm gonna say is silent. I don't know how rabbits make sound. And here, if debug, see out this message. Deleting get name, uh, the get color rabbit. Okay, implemented rabbit just like dog. We run this. Okay. Now the last thing that remains and is kind of somehow interesting probably is Poppy. In Poppy, we are implementing weight, which is a floating point number, and we are only implementing move because at this point we said that now everything having any of these member functions is optional because we implemented all those pure virtual functions. We are good to go. So anything from now on is optional, but we chose to update move here. We chose to update move. So if I come here to the Poppy, and here also choose Poppy. In Poppy, uh, I'm creating a class Poppy that this one now inherits from a dog, and because it inherits and let's say it has we said it's going to have weight for it's as its member variable, and in the public part now there is no must have and everything here is optional. So um, constructor a constructor. Did I have constructor for the rabbit? Yes, I did. And can somebody unmute and tell me what should I put now in here for things to be initialized? How many things do I need to put here? What? Armando, can you repeat, Armando, please? Yeah, I can hear you. No, it we should know what it has first. So this is a puppy, and this puppy, it, puppy has weight, so it is its own member function that we should initialize. It should be taken care of in the constructor part. It also has age, inheriting this from its parent, its father, dog, and it also has a name, inheriting it from its grandfather, basically. So there are three things that we should. Uh, Thanks, Armando. So there are three things basically we need to initialize here: constant character pointer name for its grandfather, what it inherited from its grandfather, uh, integer age, what it inherited from its father, and um, double double weight from itself. This is what it had in itself. So two things we have here that we should take care of using uh, its parent and its grandparent constructors. The other thing, we said that we're going to also uh, implement move. So let's implement move. Uh, this time it's going to give me puppy pointer move, puppy pointer move, um, and then a destructor. So destructor for this, a virtual destructor for puppy. Vir virtual virtual destructor puppy. That's it. So how am I going to use its parent constructors is a good thing to know. And for the move, we'll implement move and implement puppy. Okay, let's do this as usual. Name, and then dog, dog age. Are we good with this? Do you think? Well, obviously you see that there is an error. Um, when we have this dog, so instead of using animal, we can use the constructor of the dog, which also has the name and age. So we are sending information uh, to to its parent constructor dog, and this is it is initializing age, and it is sending name back to its grandfather's constructor name, and name gets initialized there. And here I can simply say mWeight is equal to weight, and print this message: if debug cout, uh, if debug using namespace std cout creating get name, creating this guy, this rabbit, with which is that is what, uh, get age from its father, years old, and uh, also we can implement here set weight and get weight. Let's implement get weight. So I'm gonna get a double get weight, uh, and get weight is going to give me return m weight. Return m weight. It's gonna return m weight, and here I can say and is get weight kilos or pounds, whatever. And here return m weight, we have this for the move, return this, and for the this move we have cout, get name, again get name, uh, what, uh, stumbles when walking, stumbles when walking, NL. And for the puppy, again we say if debug cout, uh, deleting get name, get name the rabbit, the rabbit, and then okay, that's it. Now we created all these classes in three hierarchy levels. Now let's play with them a little bit. First, will this, if I uncomment this line, will this run or not? Just one person. No. Exactly. It will not run. Why? Because this is an abstract class. Uh, this is an abstract class, and this it's fine. It's fine. This is an abstract class, and we cannot instantiate any object of that type. Same is true for the pet, but now I can do something here. Um, First of all, debug is true. So let's do this. Create a create a cat. Create a dog, and show the dog information here. Uh, and you see that I should see now all the moves and all the things. Now let's track it. We created Snowy the pet. Why? Because dog was inheriting itself. It was inheriting from a pet. So a pet creating a Snowy, my dog that is 5 years old, and this is at the time of creation of the Snowy the dog. Um and Snowy here for the act. Snowy is my dog that can shake hand. Oh, look at all these spacing things. No problem. You just need to understand this. And Snowy can fetch. Snowy barks all the time. This was for the sound. And now that we are reaching to the end, deleting Snowy the dog. First dog goes away. That was the second floor. The first floor is pet, and the base floor is animal. Now animal is going away, and we are good with this. Uh, Now, if we add, if we add one more stuff here. Uh, Now I'm creating puppy. P is a puppy. I'm creating this puppy, and same thing we will see. Creating, now it comes here for the puppy. Uh, it is now it's a puppy. So a pet is created first, then a dog is created after that. Well, before this, uh, there is no message, there is no constructor for the animal to show. Otherwise, we would see it would say creating Puffy the animal first, baseline, base floor, then pet first floor, dog second floor, and finally Poofy, uh, which is uh, which is a puppy. I think here I need to for the for Poofy. Yeah, I didn't add this and L. I didn't add this. And for now, coming on to the uh, to the adding another uh, to puppy. I'm gonna add this to the puppy, and let's see puppies things. Now it after it created Poofy. Now Poofy shakes hand, stumbles when walking, and barks all the time. This was the sound. And again, for when deleting, well, this is coming from the next line. Let's add that too. Uh, Animal. Now I'm gonna have animal pointer, and we want to see what this animal pointer. Let me comment these. With the animal pointer, same thing will happen. Um, this is when we said uh, it is here a puppy is being created, so a pet, a dog, and uh, and a puppy is created here. because of the virtuality, the most updated parts are being called. That's why uh, Happy is a dog that can shake hand, because it was for the dog and we didn't implement anything for the puppy in terms of its act. We didn't implement anything, and then it stumbled when walking because puppies stumbled when walking. As you can see in the level of the hierarchies, the recent one has been called uh, for act. The most recent for puppy was for a dog. We didn't implement that. Um, we implemented act in the dog, but we didn't implement that act for puppy. So the most recent one is for a puppy which shakes hands, um, and for the move, it is able to it stumbles because the most updated part is from the puppy, and it barks. Why? Again, because the most updated part is from a dog. And uh, if we add another animal pointer here, animal pointer, and see what happens there. Animal pointer. Now I have an animal pointer pointing to a rabbit, and that rabbit will show the same behavior. It will show the most updated parts up to the rabbit. So rabbit had all of these things. First of all, Bruno the pet created, Bruno the white rabbit created, and before this pet animal created. Now Bruno chews, jumps, and is silent, because all of these are coming from the basically from the rabbit part of it. And finally, if I want to, we have to deallocate memory here, and let's see what happens here in the deallocation. If I want to deallocate memory, we will see. Now after these uh, these things created, the first thing was happy. The first thing that was created was happy, deleting happy, deleting happy again as a dog, um, and deleting happy as a pet, and deleting, oh, this is because those spaces I didn't put. But anyways, you see that for all of them, starting from the top, from the last floor of the building, everything is getting destroyed until it reaches to the animal. Now the question is, what good does it make, and how we can use this, how we can actually benefit from this. The benefit we can make here uh, is that I can now point to uh, an array of all these kind of animals in the inheritance hierarchy with just their parent name, and they will show their latest acts. What do I mean by that? Imagine in the animal, I come down here, and um, let's say I want to here overload the in overload the insertion operator. So I can do this. Stream reference operator, operator, and then again std stream reference and animal reference, and in the o stream and in the animal I come here and create this thingy as saying in animal. Now I want to see all those messages, all those things of acting and moving and sounding. So I can say animal reference what? Animal reference A. Okay. And here animal reference A. Now A can act, A can move, and A sound, and I'm gonna return OSTR. Now I overloaded the insertion operator, and uh, it makes my life easy, because here in the main, if I wanted to any type of to point to any of these things, I had to find the proper pointer. But now if I just come down here and implement such a thing, implement an animal pointer array, a array that has three members, and these three members are each a different species in this inheritance hierarchy. So one of them is a poppy, a poppy, what, Bruno, 1 years old, 1 year old, and 10.23 kilos. The other one, now, see, this is an animal pointer, so it can point to any kind of these species. New rabbit, a new rabbit, call it, I've called it Tapsy, and color brown, and a new dog, named Sunny, this. Now I have created an array of animal pointer, basically an array of animal type, and this array keeps all these different type of species that we had. Now let's run this. What we see is now all these types are being created. Bruno is being created, Tapsy is being created, and Sunny is being created. And all of them are being stored in the animal pointer array. It is really bothering me. We can, and this one I have added hit, added a new line, and this one also I've added a new line. Okay, now I want to use my uh, overload to show these animals. Now I don't need uh, to create different arrays to store each of them because of this the fact that now we have this virtuality function, and we can only write the uh, overload our operators in the base class. And because everything else from there is virtual, everything will be updated to the most recent available version. So here I can say, for instance, for int I equal to 0, I less than 3, and I plus plus. I want to show these now one by one. Let's first print a message and say uh, species number what? Number I plus 1. Species number I plus 1. And and here say, now I want to show these one by one. And we just call this the content of what this array is pointing at. Array is pointing I, and then NL. So in a loop, what I am doing is simply, in a loop, every time I am using uh, my uh, insertion operator overload that we wrote here in the animal, we wrote here, every time in the loop I'm using this. So uh, basically it helps me to show all the different species that are stored in one array with no problem. Let's see, now I'm running this. Okay, after these are created, let me see, do you see this? Yeah, after these are created, now in the first round, this is species number 1 that is being created, which was a puppy. Bruno uh, uses its dog's act, and then Bruno stumbles when walking, and Bruno barks all the time. Species number 2 is a different one. It's a rabbit. So now with no problem, it shows all the uh, act and sound and moves of rabbit, even though it's the same loop, it's the exact same thing. And the next one is a dog. And the third species number 3 is Sunny is my dog, that can shake hand. It's a dog. It can fetch and it can bark. And if you look at all these uh, species, they are different species inherited sometimes from each other, but all of them stored in a base class type pointer stored there, and within a single loop and within a single uh, operator overload that we put in our base class, we are able to show them, uh, each of them, we are able to show customized their own acts and sounds and moves. So in the future, when you are creating different classes and you want to show each of these, there's actually no need to overload the operator insertion and extraction operators in each of these classes most of the time. You typically can do this trick, and this basically saves you a lot of coding and gives a lot of efficiency. Uh, okay, uh, is there any question? So uh, this basically finalizes our uh, inheritance, topic, our let me see if I can come back now. It finalizes our inheritance topics, uh, our virtual functions topic, our base class, uh, abstract base class. Um, what else? Uh, yeah, actually, all these topics we have discussed in enough detail. Next week, doing, we will be creating classes with uh, resources. So there, the difference will be that these classes will have some member functions that some member variables that will require dynamically allocating memory. Um, and we will see that how we should take care of this dynamic memory allocation and deallocation when we are deriving some classes from them. That's it for today. If there is any question, please go ahead and ask. Otherwise, we can finish it here. Thanks, Armando. Thank you, guys. Thanks for bearing with me. I know sometimes things get a little bit boring, especially when I'm just coding. Uh, it's there is no way that we can avoid that. It's basically the best way to see and to learn is to code online. So we will do this. Okay, what else? Thank you so much. Have a great weekend, and uh, we'll see you next week. Thank you, Sebastian.